Okay, this is a description of the FM-120 data and standard fog collector data and wind data that we need in order to compare the water collected by the standard fog collector, which in the picture on the poster hopefully you saw. The standard fog collector is a large piece of mesh, basically, that's catching some of the fog that's blowing through it. And the fog are these tiny little droplets. What the FM-120 are is they're devices that measure and count the number of those little droplets of different sizes. And they can actually tell you how much liquid water is in the air per unit volume. And that's the data that we're going to be working with for this Excel spreadsheet. We're not going to look at the size of the droplets. That would be another study. A very worthwhile one, but we don't have time to do that. We're just going to look at the number of droplets. So what I want to show you here is in this Excel spreadsheet, extend this down. Okay, I'm going to explain to you what each column represents, and then I'll go through and do a little practice analysis on one event, so you could do it on other events. And we have many, many events. This is just a sample of about 3 or 4 days worth of data, of about 2 to 3 months of data that we actually have, to give you an idea of the extent of research that would be possible using this data. And it's state of the art. This hasn't been, the data this extensive has not yet been collected anywhere in the world. There's some people who've done this study, but on much smaller sample than what we have in front of us here. So this will truly be a great opportunity to advance your research. All right, so the first column is the date and time. It's local. This would be daylight savings time. It was in August, and also early September. The second column, the acronym LWC stands for liquid water content. And what it means, it's the amount of water in grams per cubic meter that was recorded by one of the FM-120 fog collectors. This is serial number 109, which was placed directly behind one of my fog collectors, one of my standard fog collectors. So the mesh got some of that fog, the rest of it blew through, and this SN109 FM-120 collected it. This column here refers to the total number of grams of liquid water per cubic meter that were collected over the 10-minute interval by the FM-120 that was in front of my fog collector. So this one here in column C was collecting and measuring the amount of water before it hit my fog collector. So clearly it should generally be more, this one should generally be more than that one, and it is, which gives me some confidence that what we're doing is basically at least in the right ballpark. Next column is the wind speed, which was made independently with instrumentation that was already there, an anemometer, but we need that in order to do some of the subsequent measurements. Column E represents the difference between the two FM-120 fog collector in terms of the amount of water per cubic meter, grams per cubic meter, that were recorded over that 10-minute interval. All right, so it's the difference between them. Notice these numbers are really small right here. And of course, notice that the actual numbers in grams per cubic meter are also really small. We're talking 10 to the minus fifth grams in a cubic meter. That's not a lot of water. It's basically clear air. You can't see any of that. It's not fog yet. Now, in order to actually determine the amount of water that came out, or should have come out of my fog collector, based upon the difference between these two, you'd have to multiply the difference by the wind speed. Now, what does that mean? Why the wind speed? Well, the faster the wind's blowing, the more the droplets are accumulating on the mesh, and the more they're also getting blown through the FM-120, so the more liquid water you could expect to collect if it's in a cubic meter. So if you have only a tiny amount in a cubic meter, but you have a lot of cubic meters running through your fog collector, you're going to get a lot more water collected. And that's what column F represents. It's actually, we're starting to get closer to the volume of water. That actually would be a more closely related to the total amount of water that would have been collected during that interval, given a certain wind speed. The next column represents the amount of water that my standard fog collector actually collected in the rain gauge. I'm measuring the volume of water that that instrument is producing. That's what column G is showing us. Column H, I converted this difference over here, which I multiplied by the wind speed, but I converted it into the equivalent amount of water in liters per 10-minute interval, so that I can compare columns G and H evenly. That's the goal. Compare columns G and H. I have to put them in the same units to compare them. So columns G and H are in the same units. And column I is just in the same units as column H. It's the actual, and in the same units as column G for that matter. In liters per 10-minute interval, it's the amount of water that is being collected by the FM-120 that's in front. All right, so there's a lot of different pieces in here, but that's a basic overview of what each column represents. And this is the kind of thing that you'll probably have to look at again and again to really understand it, which is fine. If you choose to do this research later on, you can do that, and you will. I've been looking at this for a long time, so I'm getting better at understanding it. But for the purpose of this project, I wanted to give you a brief overview of that, and I'll show you what we're going to do with the data. That'll also help you understand it better. That'll be the next piece of this video. Okay, I want to show you how to actually do something with the data. I described what each of the columns represent, which may or may not completely resonate with you right now, and that's understandable. It will if you keep working with it. But I'm going to show you what I want to look at, and this will help you see a little bit better what's going on, I think, too. I want to look at the time, of course. That's going to be of interest because I want to know when things are happening, and that's column A. So I'm actually, just to make it simpler, I'm going to copy what I'm interested in into another spreadsheet so that we can just look at that and not look at all the extra things that it took to get to the columns we're interested in. So it's basically column A, column G, which is the data that my standard fog collector, the mesh, the amount of water it collects every 10 minutes in liters. And then column H and I. H represents the difference between the two FM-120 water collection amounts, each 10-minute interval. And column I represents the water collection amount at the frontmost FM-120. Okay, so that's those are the derived quantities I'm most interested in. It'll be just 4 columns. And I'm going to show you what those 4 columns tell us. And then that'll be enough information that you can pick an event and diagnose it or qualify it for me. And that would be a project, picking one event. And there's 4 events in the data set that you have here. Pick any one. I'll do the first one. So if you can do one of the other ones, that would be great. All right, so the first thing is to copy the data. And hopefully you have some experience in Excel. I'm going to hit copy. I use Control-C on my laptop. I'm going to open a new window here. And I'm going to paste that in. And then the next column I'm interested in is this one over here, column G. I'm going to copy it. I'm going to paste the entire thing in here. Column C is the next one I'm going to work with. And I'm going to take the data from column H, copy it. I'll put it in column C. Whoops. This one I have to paste special. So I'm going to go into here, paste values, and click paste, paste values, basically. I want the values, not the formula. If I put the formula in there, it's going to give me something ridiculous. So this looks like the same numbers that are in the previous spreadsheet. You can check that to make sure you have it right. And then finally, column D is going to be column I, copy, and again, I'm going to have to paste the values so I don't get the formula giving me some weird number. So paste values. Expand this. I'll center everything. Whoops. Expand this. And then center everything here. All right. And I'll make this bold so that we know it's the title. So everything's bold there. All right. So here we go. Now, if I look at all the data at once, it's going to be kind of overwhelming, but I want to show you what it is. So there's like 600 data points here or something like that were collected every 10 minutes between August 28th and September 1st. Between some time, it was 2 p.m. August 28th to sometime on September 1st. But if I look at the plot of everything together, you'll see kind of what I'm dealing with. Here's what I'm going to do to select the data. I just select this cell here. I don't want to select all the columns. It does a different type of graph if I do that. But I select the data by clicking that upper leftmost cell, and then I go down to the lower rightmost cell of the entire time series, because I just want to show you what the whole thing looks like. Okay, there it is. Press Shift, and then press I think the right mouse, and it'll select all of the data, but without selecting the entire columns. And then I'll say Insert and go to Charts, and insert that chart, and there we go. This is all of the data. And I'm going to show you what it is, and then we'll break it down a little bit. So what we see here are, I see 4 fog events. The biggest one's the first one. That's the one we'll look at right now. And there's a smaller one here, maybe a slightly bigger one than this one here, and then a much smaller one over here on September 1st. So we have 4 fog events, one day after another, which is great. I'm going to take a look at the first one. You can look at the second one, or the third one, or the fourth one. Take your pick. But I'll start with the first one. And so what I'm going to do is I'm going to say, okay, the first one extends, I'll go from the beginning of the data to about noon on the 29th. So I'm going to go from here to here. So it'll be a much smaller set of numbers, so it'll spread things out a bit more. So I'm just going to look at that data set. You would probably do something like that. You'd look at maybe on 8:29, you might pick something late in the evening on 8:29 and go through noon on 8:30 if you're looking at the second event, or vice versa for the third or fourth events. And what you see here are the 3 data sets. You got the time, of course, on the x-axis. One data set is gray. That represents the data from the FM-120, the forward one. The other data set is orange, and it represents the difference between the gray data and the other FM-120 that's located behind a fog collector. So the orange one is necessarily going to be less than the gray one, but there's a reason why I want to look at them both. Then, of course, the blue one underneath here is a little hard to see. That's the actual liquid water that my fog collector was able to pull out of the air, or out of the fog, I should say. And we're interested in actually the ratio of how much water did I get compared to how much water was actually available for me to get. That ratio is an efficiency. And that efficiency is a number that we're seeking to find for each of these events. And it won't necessarily be the same for each of these events, but I want to find it for as many of these events as possible. And I'm going to show you how we can both plot the data and look at the efficiencies. Okay, so going back to my data, as I said, I'm going to look at the data from 8:28 from the beginning to about 8:29 at noon. That will give me this entire event. All right, so I'm going to go back to my original data set. I'm going to get rid of this. And I'll just start here. I'll say, okay, I'm going to start at the top. Now, you might be able to do this more quickly than me if you know Excel well. Great. And you can see there was an event there. I saw data over here. This is the fog collector. Then it goes down to 0 again. And notice these data here, the data from the FM-120s, the numbers are bigger during the fog event than they are after the fog event ends, which makes sense. The fog event has liquid water in the air, and that's what it's measuring. So I'm going to stop it here. So my data set goes from the beginning to noon on 8:29. I'm going to insert this. It'll be easier to see the data now because it's all going to be in one plot. There we go. I'll expand it. And we can see a little bit more about what's going on. Oh, this is interesting. So I see that it doesn't look like I have a whole lot of fog water, but I do have some here. But there's a whole lot more water in the air. That's the gray. And notice it took a while for the fog collector to actually start catching the water that was in the air. All of this stuff, this big peak here, was just getting my fog collector wet, but my fog collector wasn't measuring the water. It took some time for it to drip down, basically. And in the ideal world, the stuff in the blue would ideally be equal to the stuff in the orange, but I'm clearly losing a lot of water that isn't making it from the air to my fog collector. That's what this graph is telling me, but I'd like to see how much. So I'm going to talk to you about one type of efficiency. I'm going to get rid of the orange one for the moment. I'll just look at the gray one. So get rid of the orange data. And this here, if you graph this, and you could actually say this is FM-120. Call this. I'll label this chart FM-120 and fog and standard fog collector data. Call it SFC data. Okay, this is liters. So if you had to label the y-axis, I'd label it liters. And the x-axis, of course, is time. Series 1, if I can, I don't know if it'll let me change it here. I may have to go into Excel to do that. Series 1, the blue one here, is the SFC. Series 3 is the FM-120 that's in front of the fog collectors. So I should say FM-120 in front of SFC and SFC data. Both are in liters. All right, so that's one of the graphs I'm interested in. And the other thing I'm interested in is how much water did this collect and how much water did this one collect over that time period, and what's the ratio of the two. So that ratio is going to give me the efficiency, and that's a number I'm interested in having you calculate. The efficiency of the collection, it's called the collection efficiency. How much of the water that's in the air, which is what this gray data represent, how much of the water that was in the air actually made it to be in my rain gauge and actually get measured. And some of it actually happened all the way out here. You can see there's some data out here from when the fog collector, the standard fog collector measured water, that the gray is basically zero. So there's a delay between the fog event and the actual water coming from the fog event. That's important to notice. Okay, I'm going to go in here. I'm going to do a calculation, and I'm going to do it by noting, let me see, when I have these data collected for. I went from cell 2, from cell 2 all the way down to cell 134. So cell 2 to cell 134, and I'm interested in the total amount of water. It's kind of like taking the integral underneath the curve. I'm adding up all of these values of volumes of water that happen between cell 2 and cell 134. So the way I do that is in Excel. So to find what I'm looking for here, I want the sum of all of the data that goes from cell 2 in column B to cell 134 of column B. So I'm going to say, give me the sum of all the data from B2 to B134. There it is, 0.32, and that is in liters. So over that time period, I got about a third of a liter, which is maybe a big cup of water from my fog collector. Great, you say. Well, how much was there available for it to collect from? So this is from the SFC. It's that many liters. Now I'm going to look at from the FM-120. That's SN107. That's the FM-120 that happened to be in front of the fog collector. That's just the serial number of it. Clean that up. FM-120 serial number 107. That's what this column D represents, and that's what I'm looking at right here. All right. Go here. I don't want that liters column. I'll put it there. Okay. So what I'm going to do for that is I'm going to say I'm interested in the sum of D2 to D134. So I have to say sum equals sum D2 colon D134. So that's how many liters were available. Over 6 liters were available, and I only got 0.3 liters. That's not that good, actually. That's a pretty low collection efficiency, as we call it. It's a lot lower than I've seen in other cases. So I'm interested in why it's going to be higher or lower in different cases. So this collection efficiency, then is going to be equal to the ratio of these two. So this is equal to this divided by that. Let's see what it is. So we're talking 5%. 5% collection efficiency. It's not so good. I'm only getting 1/20th of the water that I could have gotten. It's kind of sad. So what's going on? I don't know. That's part of what the research I'm looking at. Sometimes it's a lot higher than that. Why is it higher sometimes than other times? Those of you who are interested can pursue that research with me because I have a lot of data to pour through to look at this. Let's look at the other efficiency that I mentioned in the graph. And that is, so this here is called the collection efficiency, which is labeled right here. I'll make that bold, that's important. The other one that I'm interested in is called the drainage efficiency. What does that mean? There's actually a few efficiencies we can look at. Well, part of the collection process involves the water getting removed from the air, and then that water that's removed from the air making its way into the tipping bucket rain gauge and being measured. And what I'm seeing here is, I'll go back to the graph. Actually, I'm going to regraph it. I'm going to graph the data from here. I'm going to go down to 134. Go. I'm going to insert a new graph. Same kind of graph. I'll just expand it. But now I'm going to get rid of the other one. I'm going to get rid of the gray data, and we're going to look just at the orange data. The orange data represents the difference between the two fog collectors. In other words, this is less than the gray data, because some of the water that was in the fog collector that's showing the gray data was collected by the mesh. The orange data is the difference between the FM-120 in front of the mesh and the one that I have installed behind the mesh. That difference should be equal to the water that the mesh collected. This then supposedly is the water that the mesh collected, but I only see a tiny fraction of it. So the drainage efficiency tells me what fraction of the water did I see, which is the blue one, which is the same one I saw earlier, compared to the actual water that the mesh supposedly took out of the air. And what happened to the difference? Somehow the difference didn't make it. Maybe it stayed on the mesh and evaporated. Maybe it got blown off the mesh and never made it into the rain gauge. There's a number of things, but this is called the drainage efficiency. So I'm going to find the ratio of this to that, and that'll give me the drainage efficiency. And let's see what I can do for that. All right, so the calculation is going to be very similar. I'm going to get rid of this graph, but if you were to label this graph, I would label the orange one as the difference between the front and the back FM-120. And of course, the blue one is still the water collected by the standard fog collector, SFC. All right, so here goes. I can get rid of this graph too, but it doesn't matter because I'm going to do my calculations all the way up here. So this here is still 0.32. The data from the water from the SFC is the same as it was before. But the difference between the two FM-120s is going to be, I'll call that here, difference between FM-120 units. I'll make this bigger. I can wrap it around, wrap text. And to find that, I'm going to find the sum of, now this would be C2 to C134. So now we have 4 liters. So what happened was this, let me explain this. 6 liters of water were available in front of my fog collector. 4 liters of water were collected from behind the fog collector. So my fog collector should have collected 2 liters, I'm sorry, 6 liters of water were, 6.4 liters of water were in front of the fog collector. And behind the fog collector, it was more like 2 liters of water. So the fog collector should have collected 4.18 liters of water because this is the difference between the front and the back. That's how much it should have collected. How much did it actually collect? That much. So the drainage efficiency is the ratio of the amount of water that it could have collected, that it actually collected, to the amount that it could have collected. So F2, or the 0.32 liters, divided by 4.18 liters, and that gives me a drainage efficiency of 7.6%, which is pretty bad also. So it's weird. I don't know what happened to all that missing water. That's some of the research I'm doing, and I'm looking at, and is it different in different situations? That's what I'm going to be perusing and considering. And if you're interested in continuing with this work, you're welcome to apply to UROC. I'd love to have some students helping me with this. I do have a graduate student working on this, who's the one who produced this really nice data set, which we have a lot more of. We have a lot of events to look at. You're just looking at one event. I'd love it if you could do this for a number of events, and then we try to determine why is one event different from other events. Okay, good luck with that. I hope you can come up with something useful for a given event. See if you can repeat what I did for the one of the other events.